Okay, I just got recording in progress thing. To be specific, I'm not here to discuss the various Bitcoin service providers like hardware wallets or collaborative custody solutions like a Casa or Unchained Capital, or lending and borrowing services like a BlockFi. But if you have questions about that, feel free to ask me. I honestly have probably used all of them, but it's not necessarily relevant to this particular conversation. Today, we are going to be discussing the pretty technical, but in my view, the very exciting evolution of Bitcoin itself as a network, a protocol, and a decentralized layer for applications and money. So I'm not going to pretend like this is going to be super easy necessarily to grok. It's very complicated. A lot of these projects, to be honest, there's only like one YouTube video or a single podcast or a single Medium article that describes what it does. And so I'm not entirely clear on the implementation of a lot of these projects from a technical perspective. So I can't promise you complete accuracy. I will probably say some things that are wrong about some of these projects, and some of the details I probably can't explain. But the one thing I can promise you is that if you do have a question, I probably can point you to the very specific individual or company that's working on this project for you to ask that question towards. So I can always point you to a better resource than me. So with that said, let's just go ahead and get into our agenda. So I've broken this up into 5 sections. This is a lot. Don't worry about reading through all of it. We're going to start by talking about Bitcoin real quickly. Then we're going to talk about layer 2 solutions, and then we're going to talk about sidechain solutions. Then we're going to talk about contracting language improvements. And then at the very end, I just threw together a list of a bunch of random stuff that I couldn't really categorize. Honestly, I was doing this last night. I got kind of tired. I probably could have fleshed this out, but this is where we're at. And I'm sure some of you are asking already, like, what's the difference between all of these things? So layer 2 and sidechains in particular, even personally, I think the definition of those things have gotten a little bit complicated over time. Now you have a lot of projects that call themselves layer 1.5, which doesn't even make sense to me. I think the formal definition of the difference between a layer 2 and a sidechain is that a layer 2 is completely dependent on the main chain, i.e. Bitcoin, for security processes and security mechanism, whereas a sidechain can use aspects of Bitcoin for security, but also has its own standalone sort of game theory and mechanism to secure itself. So that's a kind of a very broad simplification of it, but that's historically what we see. And that's kind of true for any sidechain or layer 2 on any other blockchain like Ethereum. All right, so let's start with Bitcoin itself. So what is it? It is a decentralized protocol for money. It's also known as a base layer. It's also known as a layer 1. Its goals is to be peer-to-peer cash and to be sound money, which is kind of what's been explained in the Bitcoin white paper. Its goal is to rival central banks, to rival discretionary monetary policy, and to become the most maximally decentralized protocol. So what are some of its values? Well, every cryptocurrency and every blockchain probably says that decentralization, permissionlessness, and immutability are its main goals. The way that Bitcoin actually sort of emphasizes these different values is, one, by ensuring that there's a low barrier of entry towards validation. What this means is that a lot of the choices in Bitcoin and a lot of the biggest fights within Bitcoin has been whether or not it is important for everyone in the planet to be able to run what's called a fully validating node. So I actually have a Bitcoin node. It's in the corner right there. It's just a little Raspberry Pi. And that machine is running the Bitcoin software. And what that software does is that it validates and actually runs every single piece of Bitcoin script or Bitcoin smart contracting language that ensures that everyone who spends Bitcoin has the ability and has the right to spend that Bitcoin. And it just ensures that all the rules of the network are actually being followed at all times. And so from a Bitcoin perspective, or from a Bitcoiner perspective, that's one of the most important things about Bitcoin, is that everybody is running these fully validating nodes, that they're verifying and validating transactions. The next thing that it cares a lot about is having a very simple and predictable monetary policy. So a lot of people have heard this meme of 21 million Bitcoin. It's a really, really important part of how Bitcoin functions and Bitcoin's culture. The way that it actually works is that Bitcoin is actually itself inflationary. So every 10 minutes when Bitcoin block is mined, there's new Bitcoin that's created into the system. And the amount of Bitcoin that's generated with every block gets cut in half every 4 years. And that's called the halvening. So it has these disinflationary shocks to it every 4 years. And eventually it just keeps halving to the point in which it's basically non-existent. And then you asymptotically hit this 21 billion hard cap. Backwards compatibility and a layered approach to development. So Bitcoin, unlike a lot of other protocols and a lot of other blockchains, has this huge value around making sure that anything they do in the future doesn't break anything in the past and doesn't change anything that was considered valid in the past. And so Bitcoin tries to avoid what's called a hard fork, which is basically where you change the rules of the system in such a way that everybody has to upgrade their system to the new set of rules. And so, for instance, let's take the node that I have in the corner there. In theory, I could just leave that node there and never touch it and never upgrade it for the rest of my life. And every change that gets implemented into Bitcoin from that point on doesn't necessarily impact that node's ability to verify all the transactions that have happened in the past. I might miss out on some new features that get added in the future, but again, it doesn't break anything that happened before. And that's not necessarily the policy of a lot of other blockchains. A lot of other blockchains actually have policies of hard forking, where everybody needs to be upgrading their system to keep up with what's going on with the protocol. Otherwise, their validating node doesn't work anymore. So what can it do? The Bitcoin blockchain and most blockchains in general, they aim to kind of do the same things. It's to secure a network of data and timestamps. So blockchains are very good at determining the order in which something has happened, enable finality and settlement of value over value transfer. That becomes asymptotically difficult to reverse. So that's a mouthful, but if you've ever used Bitcoin before, you've probably heard somebody say that, like, oh, you need to wait 6 confirmations for your Bitcoin transaction before you know it's really finalized. The reason why they say wait for 6 confirmations is that because it is statistically possible, and it has happened a couple of times in the past, in which a block is mined or 2 blocks are basically mined at the exact same time, and then one ends up overriding the other. And so if you only wait 1 confirmation with Bitcoin, it's actually possible for something called a reorg to happen, where your transaction effectively gets reversed back to you, and then another transaction takes its place. Doesn't happen very often. I think it's only happened a handful of times, but that's why they say wait for 6 confirmations. Bitcoin blockchain can also act as a dispute resolution mechanism, which you'll actually see that in practice with some of these other layer 2 protocols. That's why Bitcoin can have layer 2s, is because you can have some of these resolution contracts on chain. And then finally, you can create binding contracts between parties based on redemption and spending of Bitcoin. So this is the smart contract layer of Bitcoin. A lot of people, I think, because of how well Ethereum has kind of marketed smart contracts, don't realize that Bitcoin has its own smart contracting language. It's called Bitcoin script. It is arguably a very, very difficult language to learn. In fact, if you actually have experience with programming, Bitcoin script is actually probably going to look pretty foreign to you still. It's a stack-based programming language, which is probably something you don't even learn in school. But that being said, every single transaction in Bitcoin is actually a little program that's being run. Every single transaction is actually a smart contract. There are rules being placed in every single transaction in terms of who and how a transaction can be spent. Most of them are very simple, because usually it's just as long as you hold the private key for that Bitcoin, then you can spend it, but it can get a lot more complex than that. But yeah, so those are the binding contracts on Bitcoin. All right, so the first one that we're going to talk about, and I'm probably going to spend the most amount of time on this one, just because this to me is the most exciting thing I think that's happening in all of blockchain and crypto, which is Lightning. So what is Lightning? Lightning is probably the most well-known and most production-ready Bitcoin layer 2. Its goals are to become an instant and nearly free payment communication network. So the way that Lightning works is that it takes advantage of a multi-sig address in which 2 parties, so Kyla, I'll use an example. Let's say Kyla and I are trying to make a lot of payments to one another. We have some sort of commercial partnership in which we're just sending small payments to one another. The reality is that all blockchains are not great at handling a lot of small payments. And ideally, what you would want to do is have a system in which we can communicate those transactions between us very, very quickly. And it doesn't need to be in a blockchain because, quite frankly, the rest of the world doesn't really need to know about that. I know if Kyla is trying to cheat me, and I know Kyla will know if I'm trying to cheat her. It just has to be kept between us. And so Lightning is done off chain, which is a very important thing that you'll see a lot when it comes to Bitcoin development, is trying to take things off of the Bitcoin blockchain as much as possible. So the way that we can solve this with Lightning is Kyle and I can create a shared wallet. So just imagine that we have a wallet that both of us have access to. We put money into it. And then from that point on, all we have to do is communicate to one another is basically who owns what part of that wallet over time, so that we're just communicating changes in the balance of that wallet to one another. And then at any point, if we want to cash out and actually redeem all the money, we can do that on the Bitcoin blockchain. So it allows really, really, really instantaneous transfers of value between each other. And the other cool thing about Lightning is that I can even do this with people who I don't have this shared wallet with. So let's say there's a person named Bob out there who I don't have this shared wallet with, which is called a channel in Lightning. So I don't have a channel with Bob, but I have a channel with Kyla, and Kyla has a channel with Bob. I can actually still send money from my wallet over to Bob through Lightning by essentially more or less like loaning money to Kyla to then give to Bob. Effectively, that's how it works. And that is done through something called HTLCs. So under the section that says what technologies enable it, HTLC stands for hash time lock contracts, which is technically actually two things. It's a hash lock and a time lock. It's not just like one thing, but that's what enables a multi-hop transaction. Very simply, it enables something called a payment receipt, which is really important because if you're trying to kind of funnel funds through multiple channels at once, there needs to be a way to kind of backtrack that transfer all the way back to its originator. And that's what a hash time lock contract enables. The next thing that's coming up for Lightning is something called PTLCs, which is a point lock contract and adapter signatures. This is going to be implemented with something called Taproot, which is the newest upgrade for Bitcoin. It's the biggest upgrade to Bitcoin over the last couple of years. One of the things that comes with Taproot is something called Schnorr signatures, which is essentially a new way to do cryptography, more or less, on Bitcoin. But what this enables is something called Lightning DLCs and escrows. And I will get into a lot more detail about what DLCs and escrows are later. They're kind of the same thing, actually. So what can Lightning do? So Lightning, as this instantaneous kind of value transfer system by itself, is already pretty cool. So one of the applications that many of you have probably heard about is with the news with El Salvador adopting Bitcoin as legal tender. A lot of people didn't really understand how that was working. They assumed that it meant that all the El Salvadorians were going to be making all of these Bitcoin main chain transactions. And many of you have probably heard that, like, oh, Bitcoin is really slow. You can't make that many transactions. And so there was a lot of attacks against this proposition saying, you know, Bitcoin can't handle like an entire country of El Salvador actually making transactions on it. That's stupid, which would be true if that's what was actually happening. But El Salvador is not being onboarded onto the main chain. They're being onboarded almost entirely onto Lightning. And so they're going to be enjoying essentially this feeless, instantaneous Bitcoin transfer system, and it scales for the entire country. So one of the wallets that uses Lightning that's very popular down there is called the Strike wallet. It's made by a guy named Jack Mallers, who's a really big proponent of technology. And yeah, it's going to solve a lot of issues for them in terms of payments, in terms of remittances. So we're excited to see kind of how that evolves. Another application that I don't have listed here is actually gaming. So I'm a big fan of a company called Zebedee. They are trying to infuse Bitcoin into gaming. So their product is called Infuse, which allows you to essentially stream what are called Satoshis, or a small number of Bitcoin Satoshis over Lightning while you're playing a game. So I play a game called Counter-Strike. I'm a huge fan of it. They have Infuse product on Counter-Strike, which allows you to win Bitcoin for every kill that you get on Counter-Strike. So it's a really cool product. I'm a huge fan of it. And that's only possible with something like Lightning. But beyond that, getting back to this list, fully encrypted decentralized messaging. So Sphinx Chat is a good example of this. So Sphinx Chat is kind of a Telegram / Discord / Slack-esque communication tool, which takes advantage of some of the existing Lightning infrastructure, mainly something called KeySense and TLV. So one of the cool things about Lightning is that you can actually send messages over Lightning. So you don't only get to send Bitcoin, you can actually send messages with that Bitcoin. And the possibilities that that actually opens up is actually quite amazing. Sphinx Chat, the way that they use it is simply as like a messaging system. So you can send messages from peer-to-peer in a fully decentralized manner. And essentially what you're doing is just sending a very small Lightning payment, and you're kind of attaching the message to that. And so it is, yeah, this kind of really cool decentralized application that allows you to do kind of these large chat rooms. It allows you to stream Satoshis to podcasters, which is actually pretty cool. So you can actually create a system where you are giving a podcaster like a certain number of Satoshis per minute, or I think even theoretically per second. You can do that through the Sphinx Chat application. And yeah, and so that's just like a really good instance of someone using the Lightning infrastructure to make something that is decentralized and distributed and utilizes Bitcoin. The second thing on this list is something that's very new. It's called Impervious AI, which kind of takes advantage of the same decentralized messaging system of Lightning, but they have an API essentially for developers to use that allow you to hook into kind of that data routing of Lightning. So one of the applications that exists right now from Impervious is a decentralized VPN system. So the way that they utilize Lightning for that is that you can essentially use Lightning to make a connection from peer-to-peer, paid with Satoshis, to set up a VPN system with some other computer. And the way that that works, by the way, just to explain how a VPN works. So VPN is essentially a way for when you access the internet, the server in which is receiving kind of your connection knows a lot of things about you, like your IP address and your location and a bunch of stuff like that. It's not great for privacy. A VPN is a service that you can buy where you essentially route all of your internet traffic through an intermediary. And so kind of the end resulting server doesn't actually know that much about you. All the information they get is from this intermediary server instead. So you can set this up in Lightning where you can essentially create connections and create effectively an SSH tunnel, for those of you that are technical, with another system using the Impervious AI API, and have this large decentralized VPN system, which is a huge boon, I think, for privacy in general. When you're in certain countries that have, let's say, very strict firewall requirements, something like Impervious, something like Lightning, actually makes it possible for you to use the internet essentially outside of the firewall restrictions of your own country. The next couple of things are kind of future improvements on the Lightning. So large scale payments. So Lightning right now, just the way it's kind of designed with how channels work, it's not great for making very large payments. So if you're trying to send like 0.5 Bitcoin, let's say, to somebody over Lightning, it doesn't work so well right now. It has to do with something called channel liquidity, which I won't get into. But there's something called multi-path payments, or Picard payments, named after Rene Picard, who is the developer working on it. That allows you to send very large amounts of Bitcoin over the Lightning Network, which is just great because it means that Lightning potentially can actually take over almost all payment situations that you would normally use Bitcoin for, in this same sort of feeless, instantaneous sort of way. L2, which is something I hate the name of that because it's very confusing because it sounds like layer two, but it's called L2, EL2OO, is a basically an improvement to the is an update mechanism for Lightning that solves some existing problems that Lightning has around channel management and how it saves what's called state, basically how it saves who has what, and how it deals with penalty payments. So essentially, how does it deal with people who try to cheat the system? And that's a big project being worked on. And then to round it out, DLCs and RGB, which are two separate topics, which I'll get to at the end. But that's Lightning in a nutshell. That was a lot. And Lightning Labs is a logo that I used up there. Lightning Labs, just to be clear, is not the company that is like responsible necessarily for Lightning. They are just a company that is building a lot of stuff on top of Lightning. So Elizabeth Stark, who Lynn Alden actually mentioned at one point, she's a phenomenal individual who's really pushing forward what Lightning can do. They're making a lot of products to help make managing Lightning channels easier, some things like Lightning Loop and stuff like that. But we'll get into that. You can ask questions later if you want. Okay, Ion. So Ion is probably something that most of you have not heard of before. It is actually a project that is being done by Microsoft. So what is Ion? So Ion basically is a project that is around creating decentralized identifiers. Is also known as a DID. You might see it called it that way. And the idea is that in life right now, you have a lot of identifiers that you have to manage. You have your Twitter handle, you have your email, every app that you have probably has its own username, you have social authentication, and you have all these IDs that are effectively leased to you by other companies, right? It's not like you own any of these identities, they own all those identities and all those names for you. So if you just think about how often in your daily life you're actually just identifying yourself to people, is actually constant. I mean, anytime you log into anything is essentially you verifying that you are who you are. Anytime you enter in a password, you're verifying you are who you are. So basically, the idea behind DID is, what if there was a way to actually take all those identifiers and connect them to a private key? So essentially a secret that only you know, and you're the one that's actually responsible for upgrading that and safeguarding that. And so anyone who sees your DID and can verify your public key knows that it's actually used, knows that it's actually you. So Ion does this by essentially doing that exact thing. Allows you to record DIDs from various providers like Twitter or email or various apps, attach it to a key that you own, and then record that set of DIDs onto the Bitcoin blockchain for verification. So the thing that enables it is something called Sidetree, which is the actual protocol that enables blockchain-based identifiers. Ion is technically an implementation of Sidetree, but the possibilities for this, I think, are actually pretty understated. If you think about how often you log into things and how often you are verifying yourself or verifying your credentials to people, a DID in theory actually eliminates all of that. So imagine that you have a single identifier that you use to log into everything. Imagine that every job that you have, you don't have to prove that you work there or prove that you got a certain degree from a university. They could actually sign a credential and have it placed within your DID, and that everyone knows and can verify that that's accurate and came from the provider that you think it comes from. So like if I have a degree from Harvard, which I don't, but Harvard could instantiate a credential and attach it to my DID. And so from that point on, anybody, they don't have to do any background checks on whether or not that's true. They would just know because of the way of signatures work. So, okay. Next thing is counterparty and Omni. This is actually a very old school thing. Counterparty and Omni are two layer twos that have existed since back in like 2013. It is an asset issuance smart contract platform. I won't go through all the details of how it works, but essentially it's kind of its own blockchain, but not really. But they allow you to issue other assets. And the way that it works is that it stores data about that asset and who owns that asset using something called op return on the Bitcoin blockchain, which is a way for you to just store kind of arbitrary data on the Bitcoin blockchain. It has its own tokens, and it's been around for a very long time. So actually, the first NFTs that ever existed were made on Counterparty back in 2013. And Counterparty, I think in particular now, is also what's called EVM compatible, which means that you can run any Ethereum application on Counterparty. Not to say that I don't think a lot of people have, but in theory you could. But you could use them for any type of asset issuance or tokenization. And again, these projects have been around for a very long time. Omni is actually what Tether used to work on. So before it moved over to becoming an ERC20 or Ethereum stablecoin, it was actually originally an Omni stablecoin, and those things hook into Bitcoin. All right, so I'm going to move through these a little bit more quickly, just because I know that they're going to get a little bit more complicated. But now we're going to talk about sidechains. So we're going to start by talking about some existing sidechains. The first one is RSK, which is probably the most well-known sidechain of Bitcoin. It's a smart contract platform. It uses something called merge mining, which is essentially it reuses the hash power, reuses the miners of Bitcoin to essentially validate its own chain. It's very similar to Ethereum. I mean, a lot of the way it's constructed is similar. It has its own what's called virtual machine, which is EVM compatible, which again means that you can run any Ethereum application on RSK. So if you have an Ethereum app, you have the Solidity code, you can compile it and export it and run it directly on RSK. And the way RSK works, it has a two-way bridge to Bitcoin. So functionally, the way it looks like is you deposit Bitcoin into this kind of magical address. It's a multi-sig address, but when you deposit your Bitcoin into that address, it creates something called RBTC on the RSK side. And so now you have this RSK version of Bitcoin, which you use to pay all the transaction fees for everything that you do on RSK. And it's done through a process called PowPeg, which has some special hardware with it. So in terms of what can you do on RSK? Well, with EVM compatibility, technically every application on Ethereum can be done on RSK. RSK also has something called RIF. I know there's a lot of acronyms here, but RIF is basically a unified set of tools for dApps built on RSK using something called the RIF token. But just to kind of explain what that actually means. So if you think about something like Ethereum, one of the great things about Ethereum is that there's a lot of other projects and components that you can import into your project. So like Ethereum name service or various storage or payment systems. And that's great, but it's still kind of a bit of a manual attempt at this point. Like you have to import the ability to use ENS names in your Ethereum application. With RSK, they have something called the RIF OS, which is essentially all of these things: identity, naming, storage, payment systems, kind of bundled into one thing that you can just deploy into your application really easily. So what are some instances of applications on RSK? So there is one DeFi project on RSK called Sovereign. It's probably the most well-known Bitcoin DeFi project. So Sovereign allows you to leverage trade Bitcoin with a stable coin, and allows you to also do some lending. To be completely fair towards Ethereans, its volume is substantially less than anything you'll find in Ethereum, but it is a working DeFi project on Bitcoin. Another project that I think is interesting is called Babelfish, which is a stablecoin aggregator. It basically allows RSK to take advantage of stablecoin liquidity from all other chains. So that's another project. Okay, Stacks. So Stacks is not technically a sidechain. I think they would actually get pretty angry if I call it a sidechain. They call themselves a layer one with proof of transfer. So the way that this works is that it's a separate blockchain. It's kind of a separate project. It has smart contracts. And it uses something called Clarity as opposed to Solidity, which is the programming language that Ethereum uses. Clarity is an interpreted language versus a compiled language. I won't get into the differences between that. But the way that this hooks into Bitcoin is that essentially a Bitcoin miner has the option to also mine the stacks, but the blockchain, and the way that they earn the right to mine the stack blockchain is by essentially paying some Bitcoin or auctioning some of their own Bitcoin to Stacks users. And if they're the highest bidder, essentially, then they get the right to mine Stacks, and then they get STX, which is the Stacks token, as a reward. They also get to do something called streaming microblocks, but I won't get into that. And what can you do with Stacks? You can kind of do the same thing you can do with any smart contract platform, DeFi, NFTs, all that sort of stuff. All right, Liquid. Liquid is a Blockstream product. For those of you who don't know Blockstream, they are a very large company that does a lot of Bitcoin development, but this is kind of one of their big projects. Liquid is a federated Bitcoin sidechain. It's primarily designed for traders. It uses what's called a federation. So there's actually a group of very well-known exchanges and companies that essentially care for this network and do all the validation and mining for this network. It has a two-way peg system. So again, you put Bitcoin into this address, and then you get the Liquid version of Bitcoin on the Liquid network. It's fast, it's confidential, which is actually really nice, and also allows for token issuance. The technologies behind it is something called Elements, which is the actual platform that's used to create sidechains like Liquid. So Liquid is actually an implementation of Elements. You can actually create multiple sidechains with Elements. You can actually create your own blockchain with Elements, but that's Blockstream's product. Federated two-way pegs, confidential transactions, signed blocks. Essentially what that means is because everyone in the federation that is running Liquid is basically like a known party, you don't really have to deal with all of this sort of like proof of work consensus stuff that you have to do with Bitcoin, in which, you have to worry about people attacking the network as much because you know who these people are in Liquid. The possibilities is NFTs, new assets. So that's something that could be done through something called Blockstream AMP. There are already games that use NFTs from Liquid. In the future, something called Simplicity is coming, which is basically an extended smart contracting language that will work on Liquid and can eventually go onto Bitcoin. Liquid's scripting language is called Miniscript right now. And then DeFi, actually. So there's been a really cool project that's been implemented on Liquid recently called BitMatrix, which is essentially a feeless AMM. So imagine Uniswap with no gas fees. That's BitMatrix, and that exists on the Liquid network. Okay, I'm not going to spend too much on these next two because, to be quite frank, I don't even understand them fully. It's very, very confusing. We're going to talk about drive chains and space chains, which is very kind of cutting edge stuff. So drive chains is not necessarily it's a standalone side chain. It's actually more of a category of side chains. Maybe that's the right way to say it, but the idea behind this is that with a couple of additions to Bitcoin, specifically hash rate escrows or escrows in general and covenants, and something called blind merged mining, which I won't get into how that works because, quite frankly, I don't even fully understand. You can read what my attempt to explain it was on the slide. But the idea is that right now it's actually kind of hard to implement sidechains on Bitcoin. There's actually just some mechanics of securing a sidechain, which doesn't work very well. And with the implementation of two particular technologies, BIP 300, BIP 301, a BIP being a improvement proposal for Bitcoin, which implements hash rate escrows and blind merge mining, we can essentially create unlimited sidechains onto Bitcoin that can copy the features of any other blockchain project and every other cryptocurrency. So what makes this interesting is any property of any other cryptocurrency that you find interesting or you find fun, or if you really like smart contracts on Ethereum, all of that stuff can become a sidechain of Bitcoin very easily using this drive chain technology. Now, whether or not people are actually going to use it, that's a kind of a different question. But conceptually, the idea is if you really value, let's say, privacy, and so you love Monero because Monero is the most private cryptocurrency, you can actually convert more or less Monero into a sidechain of Bitcoin, where you more or less turn your Bitcoin into a Monero style Bitcoin. So you inherit all the security and privacy properties of Monero into Bitcoin as part of a sidechain. So that's what a drive chain is. It's very experimental, but a lot of people are talking about these two upgrades, BIP 300 and BIP 301, because it would theoretically be the next big upgrade out after Taproot if we were to go after this. Space chains. All right, so space chains is a kind of a subset of a drive chain. Basically, what a space chain is a way to do drive chains now with some trade-offs. The idea being that sidechains are dependent on these escrows or these covenant sort of contracts coming to Bitcoin, and they are coming already through something called sig hash any pref out and something called op CTV, which stands for check template verify, which I'll talk about a little bit later. But these are basically two kind of upgrades to the contracting layer of Bitcoin that will allow for some of these escrows to occur, which would then allow space chains to occur. So space chains kind of gets away with doing what drive chains do in kind of a hacky sort of way. So same sort of deal. The idea is that you can create unlimited side chains that have unlimited properties of any other cryptocurrency or any other blockchain project and have it exist as a side chain to Bitcoin. The thing that makes space chains a little interesting is it uses something called a perpetual one-way peg, which I'll get into. Basically, the way that works is, let's say you have a Monero sidechain for Bitcoin. The idea is that, well, the only reason why you would ever want to use a Monero sidechains is if for some reason you want to have an extremely private transaction, right? Why else? What would be the purpose of just holding kind of Monero if there's really only kind of one specific utility towards using it? And so with space chains, the way it works is that in order to use the Monero sidechain, you would actually burn Bitcoin on the main chain, which means you effectively delete it or like permanently lose your access to it. And then you get your Monero version of Bitcoin on the sidechain, which then you immediately use for kind of whatever utility that you want to use it for. The thing that makes it interesting is that it's trying to essentially eliminate all the speculation out of cryptocurrency. The idea being that if you need to use a particular chain for some type of specific utility, like paying gas fee for a smart contract or using it for a private transaction, there's no reason to hold that cryptocurrency and to speculate on the value of it. You should just get it to use it and then be done with it. And so the idea behind space chains is that that's kind of the idea behind it, is that you would use your Bitcoin to essentially gain access to these services, but you would just be essentially paying to use the service, and you would never just hold on to a new token for no reason. And so it's kind of a speculativeness less way of doing sidechains, which is kind of interesting. Again, I don't know if people actually want that. I think people like tokens and like speculating on these things, but in theory, you can do all the things that all the rest of these cryptocurrencies do with essentially no sort of speculation to it. That's kind of the idea behind space chain. Okay, contracting language. So op check template verify requires something called BIP 119. It enables covenants and escrows, which essentially the idea behind a covenant is, right now in Bitcoin, you can have a lot of control of who gets to spend Bitcoin and when they get to spend it. So you can put restrictions on a particular Bitcoin in terms of how long you have to wait before you spend it and who actually gets to spend it. However, you can't really say anything about who gets to spend it afterwards. So if somebody has the ability to spend a Bitcoin, then they can spend it to whoever they want. A covenant, in theory, can actually control where a Bitcoin can go after you gain control over it. So there's some kind of issues with having something like that on Bitcoin in general. Some people are kind of concerned that if you have all of these covenants that control where Bitcoin can go, it actually kind of defeats the purpose of Bitcoin a little bit. But there's a lot of implications around how covenants affect the congestion of Bitcoin, Lightning channels, your ability to create drive chains, and your ability to create vaults, which is basically a special wallet that has some more flexibility around how funds can be withdrawn from it. Sapio is a programming language that makes it easier to write smart contracts for object template verify. So both object template verify and Sapio are primarily being led by a guy named Jeremy Rubin, who's been a longtime Bitcoin core developer, and this is kind of his pet project. DLCs is actually a really big one. I actually think a lot of attention in Bitcoin and blockchain in general is going to be based around DLCs over the foreseeable future. It stands for discrete log contracts. Again, just a lot of buzzwords, but the idea is that one of the big problems with blockchains is that it doesn't understand anything that's happening from the outside world. So if you want to make a bet with somebody, let's say I want to make with Kyla, make a bet about what the price of Bitcoin is going to be on, December 31st, 2021. It's kind of hard to actually write that out in a smart contract right now, because you have what's called the Oracle program, which means that there needs to be somebody outside of Kyla and I that actually verify what the actual price is on December 31st, 2021. You have to be very specific about what's the source of the price that you're actually getting this from, and how do you verify the legitimacy of that claim. And so DLCs are what's called Oracle-based contracts. So kind of this whole kind of prediction market field of things, which allows two parties to enter into essentially a bet with one another, in which a third party, an oracle, essentially validates and authorizes the payout of. So this sounds very specific, but basically any sort of prediction market, which also includes a lot of derivative markets. Like if you can think about what I just mentioned between Kyla and I kind of predicting the price on December 31st, 2021, that's starting to sound a lot like an option, actually. That's kind of one of us making potentially a call option or a put option in the future. And so you can actually construct these things directly on the Bitcoin blockchain. So you can actually do this on Bitcoin, where the actual contract is written on Bitcoin, but some of the stuff is off-chain. But it's also coming soon to, well, it actually already exists on Lightning, and it's going to get better with Taproot. So one website that you guys can check out that allows you to do this is Atomic Finance. Atomic Finance is basically, that is a prediction market that is completely based around Bitcoin DLCs. And so the idea is that a lot of actually DeFi in general are essentially DLCs to begin with, and you can do all of that on Bitcoin. One other thing that's actually pretty interesting is that with the introduction of DLCs, you can have what are called USD stable Lightning channels. So if you want to have a Lightning channel that is always statically pegged to a certain USD price, like $100 Lightning channel, a DLC will allow you to essentially constantly rebalance that Lightning channel to the correct US price. So to shorten why that's interesting is you can actually theoretically eliminate some of the need of stablecoins with DLCs. All right, the last one on here is RGB. I won't get too much into this, but RGB is basically another off-chain mechanism for doing smart contracts. It uses something called client-side validation to keep things off the Bitcoin blockchain. But essentially imagine smart contracts, but on Lightning. That's essentially what RGB allows. So you get to make all these cool DeFi applications and NFTs and asset issuance, but you can do them all on Lightning, which means they're instantaneous and free. So RGB is very experimental. I think, to be quite frank, they realize that there's a lot more issues in RGB than I think they originally realized. It uses something called a DAG, which I believe stands for directed acrylic graph, but it's kind of like an offshoot of like a blockchain essentially. But anyways, RGB is something that's coming as well. All right, to end off, a bunch of random stuff. Mint Layer, which is a two-way pegged sidechain that uses a proof of stake. There's actually a couple different projects out there right now that are trying to create proof of stake sidechains to Bitcoin. And you don't have to get too much into it, but there's a couple projects that are thinking about this. Mint Layer is one, Nomic is another, but to be honest, I haven't done a whole lot of research into them. Mini Mint and Chaumian Mint, or federated Chaumian mints. It's a very technical term, but basically it's a mechanism that allows you to exchange your Bitcoin for a different cryptocurrency or different currency, or even just a different version of Bitcoin, in a fully private and secure and scalable way. But you can do that with a custodian. And so imagine having the ability to have your bank as a Chaumian bank, where you are exchanging your Bitcoin for some fiat and then be able to convert that that currency back into Bitcoin. It can be done through Chaumian mints, and the great thing is the bank basically doesn't know any information about you, and doesn't have any say about whether or not you can redeem the currency back into Bitcoin. Very theoretical, very experimental, but that's kind of what a Chaumian mint is. Coin swap and coin joins is ways to hide where your Bitcoin came from. The difference is a coin join basically mixes your Bitcoin with a lot of other people's Bitcoin, so people can't track where it came from. Coin swap basically is a mechanism in which you swap ownership of a particular Bitcoin with somebody else. This is something that already exists. Taproot makes it substantially better because it makes it impossible for the government to even identify that you participated in a coin join or a coin swap. And then the final thing is TBD 545666975. That is the Twitter handle that Jack Dorsey of Twitter made for a new DeFi project that he is working on for Bitcoin. He has given absolutely no details on it. Nobody knows what it is. We don't even know if it's decentralized, but we know that he's working on it. And Jack Dorsey is a huge fan of Bitcoin and a huge fan of building things for Bitcoin. So we are excited for that. We don't know what it is, but hopefully it's going to be cool. So that was a lot, but I think that was it. That is effectively every single improvement, proposal, project that I know of on Bitcoin today. So to kind of wrap up, what are kind of the exciting things that are happening on Bitcoin? I think the most exciting things is Bitcoin is attempting to create a infinitely scalable, instantaneous kind of financial layer for the world that does it securely, but does it in a way in which removes a lot of the inefficiencies and a lot of the user issues with using blockchains. And they're trying to do it all on top of Bitcoin. So that's more or less what our goals are at this point. So happy at this point to take questions. I know that was a lot. Again, I don't necessarily have answers to every question, but I know the specific person that you should probably ask.
All right. We've had a question about adoption in the chat. There's several questions if you want to just like go back through this.
Okay, I'm happy to, I can just start at the very beginning, and if the person who asked the question wants to get off mute and ask the question, feel free. Okay, actually I can ask this first one. So Deepak, what protocol does Impervious use? Lightning. So it uses Lightning. Yeah, so basically the way that it uses Lightning is that it uses Lightning to actually set up the connections between two parties. So since you have kind of this whole private public key infrastructure on Lightning, you use Lightning to essentially negotiate the connection and negotiate the rate, the number of sats that you want to open this connection. And then I believe that the actual connection itself is an SSH tunnel that you create between you and the counterparty for the VPN. Okay, how do I stay informed of all these things? I don't have a life. Let's see, Kyla. Gosh, yes, directed acrylic graph. Yeah, directed acrylic graph. DAG software in general is actually kind of interesting. So there's been actually several attempts to create DAG-based blockchains. So if any of you have ever heard of Nano or IOTA, which they kind of annoy me, the community is annoying me a little bit, but whatever. They're DAG-based cryptocurrencies. So DAG is basically a different construct than a blockchain, but it kind of serves the same purpose. That's kind of what it is. Okay, so adoption. That's a really good question. So I think this is kind of the big kind of question in the air, which is, Bitcoin has this very conservative, slow methodology behind designing and developing all these things. And the reality is a lot of attention has been drawn away from Bitcoin onto other projects. I mean, it's hard to debate that projects like Ethereum have gained substantially more attention. The smart contracts and the applications and the dApps and developers that have come over to Ethereum, it's a pretty big network effect that's kind of hard to beat. I think the ultimate vision for Bitcoin is we want to have all these products available, but the reality, I think, for a lot of Bitcoiners, and I think we kind of have come to accept this, is that there's just a lot of things that we don't necessarily even care to have built on Bitcoin. Like a lot of the things that have been built on DeFi or been built on NFTs. I mean, I don't think even a lot of Bitcoiners want to see that built on Bitcoin. So even if we did create systems, and even if we have existing systems that could do those things, whether or not we can actually attract developers over to it, I think is an open question. I think one of the things that some Bitcoiners I think are expecting is that as the rest of these protocols consistently either fail due to technical problems, due to governance problems, or due to just user experience problems of just the fact that so many of them are trying to put everything onto this layer 1 blockchain, which I think to most Bitcoiners just sounds like a really dumb idea to even try to do that. Just inherently doesn't sound like it will work. That over time, that those developers and those users will come over to a system that has been foundationally sound from the beginning, and it has actually thought through all the implications of scalability and speed. And in theory, some of these Bitcoin layer 2s do that a lot better than what you can do on any other blockchain right now. But again, whether or not that's enough to actually overcome the network effect that some of these protocols have, that's kind of an open question. I think that's a legitimate concern. In terms of adoption, actually, the one thing I will say is that Lightning actually has quite a bit of adoption. So if you look at the number of people who are running Lightning nodes and the number of people who are using Lightning on a daily basis, it is increasing very, very quickly. I mean, if you think about the fact that, I mean, pretty soon here, I mean, probably, I don't know, 30, 60 days, more or less every single citizen within El Salvador is going to have Lightning and will probably use Lightning or at least have to accept Lightning, which is not great that they have to do it. But the fact that they can do it, I think makes Lightning a really interesting proposition. So Lightning, I think, has a lot of adoption. RSK has some adoption. So Sovereign is becoming pretty popular of a DeFi application among Bitcoiners. But again, because it's not built on Ethereum, a lot of people in the ETH community don't really know about it, don't really care about it. It's kind of an uphill battle to attract users. Joshua, okay. Getting involved in one of these projects, what should I focus on? In my opinion, you should focus on Lightning. I think that's probably where most of the action is right now. Most of the most interesting applications and upgrades to Bitcoin are happening on Lightning. There are several people that I know that are currently working on Lightning applications. A lot of stuff that's happening with Impervious AI, I think is really interesting. They actually have a hackathon happening soon, which I think is going to be really fun. Unfortunately, I'm not a developer myself. I wish there was more I can actually contribute towards this ecosystem, but I think just learning as much as I can about it and trying to inform others is probably the best I could do. But in terms of things that you can ignore for now, I think you can probably ignore sidechains for now. There's still quite a few upgrades and potentially kind of contentious upgrades that have to be made to Bitcoin to actually enable some of these things. So unless you really, really want to get deep into the weeds with kind of the cryptography and the game theory behind designing those systems, it's probably not something that I would suggest that you get into. All right, I think those are all the questions. If you have any other questions about Bitcoin, about how Bitcoin itself works, I know I kind of glossed over that. This is a very technical talk, probably for a lot of you. Also, if you have any questions about Bitcoin service providers, you can always ask me about that as well. So anything about wallets or custody or lending protocols and things like that, happy to talk to you about that offline as well. But otherwise, I think that is it.
Thank you so much. This is so good. I'm gonna have to watch it. I was talking about it in the chat. Gonna have to watch the recording a couple times. Yeah, no, thank you so much, John. This is awesome.
Yeah, no problem. Well, thanks everyone for joining. Again, feel free to ask me questions or ping me on Twitter if you want. My handle is just John Syu, JONSYU. And if you have a question, you can ask me there, and I can probably just tag the developer of that project, and you can ask the question to them. So thank you, everybody. Have a good day.
Bye.